Good evening and welcome to Science is Your World. My name is Andrew Hebda. I'll be your host this evening. We have as our guest this evening someone who's actually becoming a veteran on the program here, Mr. Lawrence Taylor. Lawrence is a freelance underwater photographer, a man of many trades. He's shown us some phenomenal insights into things that go on in freshwater, specifically in Grand Lake, Shubenacadie Grand Lake, and associated streams. And tonight he's going to take us for a little bit more applied tour, but into the saltwater. Welcome.
Right, thank you. Yes, well, I think we better jump in right away. We've got a bit to go. I guess it's a little bit different than what we've normally done. Instead of some nice scenics and fish and so on, we're actually get into one species only this time, which will be sea scallops, and some science done a couple of years ago.
This is science of edible species this time.
Yes, and directed towards the aquaculture industry. OPEN, which was a large federally and privately run project concluded about a year or so ago, was designed to look at sea scallops and cod. And there were a number of groups at 5 different universities looking at various stages of the animals during their life cycle. So we were looking at the juveniles, and specifically the possibility of seeding them on the bottom.
Now, the purpose of this program, as I recall, was to get the basic information about the animals, the information that wasn't there in the first place. Is that correct? Or?
Yes, and to know a little more about the ecology in some of our bays. And particularly, we were going to look at Lunenburg. Right.
Okay.
Well, I guess we should run the tape and take a look at our animals. You can see, now these are not these are wild animals. These are not some of our seed at all. The seed we were dealing with were about the size of your thumbnail. These are nice, large delts that you'd find on cobble bottom, sometimes muck bottom. But these are nice, healthy individuals.
10, 15 years old type of thing? Or?
They can be, especially these large, what they call dinner plate-sized animals. Now, we're going to do, some people are not squirmish here, we're going to do a little dissection. But actually, I think some people are not quite sure where the scallop meat actually comes from. We sort of know the scallop shell from shell oil. But the meat we often see is just little white lumps in the meat store or at the fish counter.
Yeah.
And we actually see here where they come from. Now, as we open up the animal, we can see a fairly large, sort of crescent moon-shaped mass. That's the gonad of the animal. Now, what's interesting is that it's not sold here to consumers. It's more a European taste. So we have a tendency to throw the gonad and the rest of the animal out and keep only this large muscle, which you can see is almost in the center of the shell.
Sounds a little bit perhaps wasteful from one point of view.
A little bit. There might be use for the other parts of the animal, but at the moment we just don't have a market for the gonads, or people are not attempting to venture into that market. It's strictly for the muscle. And here we can see the large muscle. Now these, what you normally find in the fish market, this muscle would be about 4 of what you normally find. This is a large piece of muscle. And this is the one that actually closes the two shells together. Now, the purpose of our research was to take, you can see in the center there's a tiny little scallop. Well, that, again, is about the size of your thumbnail. That's what we were seeding, and we were hoping to have animals grow to the mid-sized shell there. That's about a commercial size, and what you might expect coming off the banks and offshore fishing.
So by seed stock you refer to as something that's an adult shape but much smaller.
That's right, and also not sexually mature yet at all. And of course that very large shell was what you might find naturally in areas that haven't been fished by something like this, which is a scallop drag, which runs over the bottom. Now, essentially what the program would be doing and the long-term aquaculture system would do is essentially enhance a bay of scallops. Many of our inshore waters now don't have enough scallops to make it commercially viable for fishermen to go out and fish them. So it's been successful in France and New Zealand and particularly Japan, seeding areas. But you need to know the ecology of your bay before you can go ahead. So with our project, we had a small Cape Islander here, about a 21-foot boat, which we used as our diving platform. And we eventually had 3 sites in Lunenburg Bay. You can see our boat here. We traveled in all weather. I think put in some 290 hours over 3 years underwater. And at one point we could boast where we'd been in the water at least 2 days every month for about 2 years.
This is boasting, okay. Just checking the use of that word, that's all.
So you can see our boat was always full of gear. We had about 4 divers at least going in when we were out in the water. We have tanks. The yellow boxes there were camera gear. The black boxes then were current meters, so we could actually follow the flow of the water in the areas that our animals were being seeded. We had time-lapse gear. And then we would venture off to our sites from the government wharf in Lunenburg. Now, just to get through our first pilot project, which was run in 1990, we seeded 10,000 animals in an area of bottom about the size of 2 picnic tables and followed the dispersal of those animals.
This is nice you're going to raise.
Yeah, this is just to impress you that, yes, we were quite the voyageurs.
Very hardy people here. Sorry.
Yeah. But we followed these animals by laying out a grid system and putting quarter-meter square quadrat and flipping those metal quadrats over the bottom day after day. Each survey took about 3 days and about 3 hours per diver per day.
Very intensive.
Awful stuff. We were so cold by the end of the day. It made us think if we were going to move into a larger areas, that we couldn't do this methodology anymore. It was just too cold. So we adapted this. We took a high 8 camera system, and it has a housing that goes with it, a couple of lights, and you can see that long T-bar coming out of that. This ensemble we used to actually run across over the bottom, sort of like a lawnmower. We go up and down over our seeded area.
Oh, this would be your transect signal, right?
Yeah, so in a second we'll see one of our transect lines. But this then allowed us to cover an area which, instead of being sort of 25 by 50 meters, we now had area that was 50 by 100 meters.
So this is manually pushed, or?
Yeah, so I myself held onto the camera and then ran along the transect line. Now here you can see me pointing out the live. It was actually, when you got into the lab, you couldn't tell live from dead shells. So in the field, I actually had to point out the live animals, the live scallops, and I would also distinguish any cryptic crabs and starfish, who we later found out were our most important predators at the sites. So with this then, we have, as you can see, a number there. So we had an X coordinate, and then with each transect line, we knew where it was along a Y coordinate. So we could actually pinpoint where animals were dropped and look at the general dispersal of the animals as they moved around in the site.
So when you placed them in, essentially, you just released them at the surface and let them settle wherever? Or?
Yeah, and I'll show that a little bit later. This is then just back at the lab. Instead of spending 3 days in the water, laboriously using the quadrats, we then spent 3 hours in the water and then came back to the lab and then went through the tape.
So you actually got a lot more data than that, right?
Yes, yep. And so with the data, we could then give counts of wild and seeded scallops, their locations, X and Y, and also then take lengths of starfish and crabs, and even some of the large wild scallops to give us an idea of the size of the population, and also get some idea of how our scallops were growing also, because you could see that. To help identify some of our seed, we actually painted several thousand at each seeding.
Tester's play an animal, is it?
Oh, what a chore. You have to pull them out, dry them a little bit, grind the surface just a bit, and then put on a bit of, I think we used, the best was touch-up paint from cars. And then with many of them, we actually put B tags on and then took their length, so that when we found them later...
Could remeasure them. Yeah.
That's right, and then we could determine how much they were growing in the field.
So how large are these?
Again, they're about thumbnail size. Now, one other experiment that we ran around our big seed sites were tethering experiments, where you can see the stake in the ground there with the number tag, and there was a little bit of fishing line that ran over to our seeded scallop there. You can see just to the left and the bottom of the screen. This meant that the animal could escape from a predator but couldn't get away from the site. And here we wanted to see who was going after our scallops. and what sort of mortality rate would be incurred.
Perhaps this is the place we should actually point out that scallops aren't little sessile little bottom.
Not at all.
They're
and we'll see a little bit later. Now here's a starfish that actually has captured one of our tethered animals.
so it's
And you can see they're like
just the edge of the shell there. Isn't
yeah, just the edge. You also notice they're like Velcro. When you're trying to take those starfish off your gloves, it's not an easy feat sometimes. So this is one of our individuals who has become a meal for a starfish.
This is a principal predator then? Or?
Yes. Now we suspected that lobsters could also be potential predators, but maybe perhaps due to the size of our animals, we didn't feel that they were a big threat. Crabs certainly were, and I'll mention this a little bit later. At our third site, crabs can eat a lot of juvenile scallops. They pinch off the margins, and then they can stick their claws in and start tearing away at the inner parts of the animal.
So you snap the eyes off, and then...
Yeah, and...
is this a natural degree of sediment that's floating through their food, or is that just because you're swimming in that area?
A little bit of both. I can always stir some up, but there's, in our site, there's always a possibility of, depending on how rough the weather was around. Fish, flounder, and so on were also possible predators. Now, our first seeding in '91, at our two larger sites, we used a sluice system, and animals would be then dropped into the sluice. We had a little pump over the edge of the boat which kept water flow going, and this would sort of simulate how it might be done if someone was to run an aquaculture site. There was a seeding box to which we tried to drop animals into. Then we monitored a much larger area so that we could see if the animals were moving out of the seeding box, and also watch the predators if they're moving in on unusual numbers, coming in. So you've just seen our boat go by. A number of animals have been dropped over the edge of the boat, and they'll start to fall down like rain here.
Little pamphlets during the wartime.
Yeah, it's sort of like fall leaves.
So very similar in density to the water, then not that much of a difference?
Which now
your seed stock then?
They're a little denser than water.
Yeah, but not that much though, by the looks of it, not at the rate of descent.
Well, I think it's partly because of the shape of their shell.
I see.
That they, very flat profile, so they have a tendency to go from side to side because they have a large surface that has to pass through the water. So they fall like leaves to the bottom. Now this is our third site, and so the animals are dropping into the seed area, and you can see that their numbers are fairly high. This seeding, there would be about 20,000 animals that were being dropped in.
And so the actual density isn't a problem necessarily from the point of view of food availability, or that's one of the things you're looking
Well, that was something we had to look at, but it's also something you'd expect, the densities. You also want to boost the density in the area. You don't want to make it too thin. Now, here are the animals then on the bottom, and they fall right side up and upside down, and you can see there are several color morphs. There were sort of white up top and bottom shelled animals, and then those with a lighter bottom and darker top. It turns out neither color made a difference as far as predation by crabs in the area.
The predators can't necessarily see those colors.
No, a lot of the predators seem to be triggered by movement, because we're not sure that the scallops presented much of an odor when they were dropped. Now, they may have when they were first, because of some being broken and so on. There may have been an odor introduced while they were being sluiced out into the site.
Fairly rapid invasion of predators.
Yeah.
Is actually what you found? Or?
Well, at this site, that happened. We found that the crabs went through a feeding frenzy. And here's one of the little culprits right here. Now,
happy hour, right?
Oh, it was unbelievable. There were just crabs everywhere. Now, this one's a little bit bashful. Doesn't want to eat in front of us and kept moving away from the camera.
Okay.
But you'll see that there are a number of crabs that we'll bump into during the shot.
And which species is that of crab, do you know?
This is the rock crab. Yeah. Now, we travel to the bottom. You can still see a number of seed animals on the bottom. And he's going to get a friendly or unfriendly little poke from a fellow crab in just a second. There are just so many of them in this site. And
Oh, I see.
you see here. A definitely invaded the other's territory.
This isn't a feeding territory, but rather a...
Well, it's, you know, they would have hiding spots,
Yeah.
and they would prefer not to be disturbed by somebody else.
Yeah.
So yes, what we found at this site was that the crabs went through a response in not necessarily attracting more crabs, but that the animals in the area became essentially excited, and they ran around very quickly eating as much as they could.
Which would then stimulate more to come in and...
Well, we didn't find that our densities increased to any significant amount. It's just that the activity of the animals was the cause of the mortality. And in fact, what we found is that within about 8 to 10 days, we had lost 80% of our animals, and predominantly due to crabs. The tethering experiments also helped to show that.
Is this another site then, is it? Or?
No, this is the same site, and this is an animal that just finished a swimming or escape response. What I was really pleased to show some fishermen was this sort of footage where the animals are swimming, and many of them did not know that scallops can swim. And actually their shell is designed just like the wing of an airplane for lift. What's incredible is that they fly their wing thin edge first.
Yes.
So that's not an easy maneuver.
No,
Makes it much more unstable.
This is the original jet set.
Yes. So they have the two shells they draw apart, and that's actually done sort of passively by a material in the hinge of their shell, acts like a spring, and it pops the shell open. The big adductor muscle, the one we like to eat, is what actually pulls the shell together. And they have sort of little veils at the edge of the shell. Those veils hold in the volume of water. The big muscle contracts. The water is then squeezed out past their ears, and there's an ear on either side of the hinge. And so the animals actually jet through the water, and then the shell helps provide lift. And so it's sort of a series of contractions, jetting, pushing themselves forward, and then floating a little bit.
So rather than having siphons like some of the others, they're just using the
yeah, their mantle can maybe act a little bit like a siphon and direct somewhat, because these animals have ability to sort of turn left and right and around, depending on who's attacking them.
It sounds like a
in
muffler
what
thing,
direction.
doesn't it?
Yeah. But you can see they get themselves at least 6 feet off the bottom sometimes, and when you add current to that, they can actually travel a fair distance.
Do they go go in random directions, or they face into the current, or if I can use that word?
It really depends on why they're swimming. Okay. If there's a starfish after them and it comes in from a certain direction, well, obviously then they're going to try and go in opposite direction. If they're moving because they, may perceive a better food supply somewhere else, then it may be directed. We could not tell particularly.
That's perhaps something to point out also, that scallops aren't blind. They have...
That's right. They have many eyes. Now, they don't see the way we do, but they do see form. And they see forms like our crabs here, which we had tried to alleviate some of the crab pressure by using crab pots.
It wasn't a hairdryer, really.
No. Now, the seeding we've just talked about was during the summer when the water was in the mid-teens. Here, the activity of the animals should have been fairly high. Their metabolism would have been high. And we felt that maybe they could swim away from the crabs.
Yes.
But, of course, then the crabs, their metabolism also would be as high, and they're just able to keep up with them.
What's the optimum temperature for the scallops?
Well, they seem to become much more active after about 5 or 6 degrees Celsius. Okay. After that, everybody likes to tend to go to take a break and not swim as much. Right. And the seeding we just saw now was done by hand this time. And this was also done in the spring of '92.
This is much higher densities, then, is it, essentially?
These are roughly the same densities. Because of this site, not as many animals. We didn't want to feed the crabs, so it didn't work as well this time. But the water now was 2 and 3 degrees. And this was to see whether or not, with the colder temperatures, if the actual physical activity of the crabs was down, that the scallops may then get a jump ahead of the crabs.
Right.
Unfortunately, it just took 3 weeks longer for the crabs to do the same job.
Kinetics, eh?
Yeah. Now, we just passed through our stand, which we had time-lapse camera set up. This was a high resolution black and white camera. It would actually take 4 frames every 10 seconds.
Okay.
And this allowed us then to film for several days. We also had an infrared lights with the camera system so we could film at night.
Oh, I see. I was going to say that you're not going to pick up any heat from those things.
No, no, and it was just meant to see activity at night.
Right.
The animals and ourselves would not be able to see anything, but the camera certainly could have.
Mm-hmm. These were automatically set then?
Yes, they were triggered.
So you would photograph in bursts. I see. So you got predators coming in.
Yes. Now this is actual real time. This is not time lapse. And this is to give an idea of the speed of a crab moving through. Now just below the time code, you'll see a crab who actually pops up. I had no idea the animal was there until I saw this footage. I had set up the stand and the camera and the quadrat, and half an hour later, this animal popped right up out of the mud and from underneath a rock.
See, he read your research proposal before you did, you see. So.
That's right. Perfectly cued.
Now he's foraging, or he's just...
well, I'm not sure if he's a little bit disturbed or if he's actually starting to forage, but I mean, he's walking over. It's a little bit hard to see some of the animals, some of our seed there, like the smaller white dots. But I'm not sure whether or not he was scavenging or looking for prey or just deciding to move on. Now we're into the time-lapse sequence, and you can see things are a little bit jitterier, but you also see that the time is passing much quicker. Now you'll see during the daylight hours what we saw were a lot of crabs moving through. You see some flounder quickly popping in and out of the shot. And it was interesting, when dusk came along, the crabs disappeared.
Really?
Yeah. Only in the evenings it was the domain of the lobster.
Who eats the crabs when the lights go out?
But within the daylight hours, over an 18-hour period, there were 64 crab sightings with this footage, and all of it was during just sort of pre-dusk and just as the sun was rising.
Crepuscular.
Yeah. Now this is the great part of time lapse. Here's a starfish who's testing 1, 2, 3 of our seed.
Right.
He is now testing a 4th scallop, and for some reason he doesn't elicit an escape response, but he'll come to another one, bing, gone. So it's curious what's going on. This actually shows that there's an interaction going on between the starfish and the scallop, which we know has the ability with little tentacles, along with all its eyes, it has tentacles, and those tentacles do have taste and touch. And so they can actually detect the presence of a crab and a starfish.
So they're both tasting each other.
That's right. They're tasting each other.
Yeah.
And for some reasons, now here we have a lobster passing through. For some reason, scallops will move away sometimes. They either detect that there's a threat, or they won't, and they just sit there and close up and wait it out.
Huh.
This is another starfish passing through. And I like the way they wrap those arms. And, we think of them as not having much of a mental ability, but they've got 5 arms with all that tasting and touching going on.
With
it's
an eye on
quite
each
a feat.
foot type of thing. An eye on each foot. Say, whose hair is that dangling in front of this piece of
it's a piece of
Woodbine or something?
Yeah. Yes, because of the tidal movement through the areas, we did occasionally pick up a fair bit of debris.
Any brittle stars in there too, or is it strictly
very cryptic and nothing of concern for us.
Right.
This is to show the personal space of scallops. These are much larger animals. They do not have to worry about crabs feeding on them, but they certainly like their personal space.
Is this almost 1 meter by 1 meter that you're looking at?
This is a ½ meter by ½ meter. Okay. So these are fairly large animals, and you can see they sort of huff and puff at each other, blowing silt in each other's faces. These animals are no longer able to swim like our seed, and have to do with bumping along the bottom. They still have their jet propulsion, but it's just not as effective.
It's jumping up in the water first.
It's jumping and bumping.
Yeah. Do they aggregate in these clumps, or these?
No, actually, I just put this group together to show their displeasure about being together.
Oh, that's the spitting you're talking about there.
Yeah. Now we'll go on and we'll see a lobster pass through. But the results that we had from the 3 years of work is that at this third site, then, of course, it was not successful. The predator load of crabs was much too high.
So we should be raising crabs at that site.
Yeah, there would be a better market for the crabs. The second site, we did well, except it wasn't predation why we lost our animals, it's because they seemed to want to go somewhere else, and they swam out of our site. The very initial pilot site was our best, and we retained somewhere around 40 to 30% of our animals, which is good.
Yeah, that's good, is it? Okay.
Yeah. Much better than some of the European and other groups who get 5 to 15%.
Now that's using the same species or different species?
Their own, their indigenous species.
Right.
So, here we had 3 sites. One that was very successful, one that was moderately, they were somewhere else out of the grid that we couldn't survey,
right.
And a third site which we thought was prime was just not not to be.
Yeah. Gotcha. Well, I understand that back up until the advent of modern harvesting technologies, that actually scallops were much more abundant throughout, especially in the near-shore areas.
Very.
So you're looking at areas where these things were common before?
Yes. We were particularly looking at Lunenburg because there was a strong inshore fishery at one point, and areas like Mahone Bay now, there's not a fishery. And it was the first, somewhere, I think 1886, where its first batches of scallops that came in from those areas, and a very strong market. Yeah. The only other strong inshore area is then Digby, which started up somewhere around the 1920s. And unfortunately, we were just too successful at removing the animals that now our only supply is really the offshore.
It's nice to be good at something. Also, in the last moment we have before the program's finished, what are your? Is this an ongoing program, or this is essentially the?
No, this project is closed. It will work if fishermen consider working in a cooperative basis, because you really need an entire bay to get this sort of project to work. Mm-hmm. You need to collect the spat. The spat then are grown out and then seeded in the bay, and you need an entire bay to do this. I mean, you're talking of animals of up to 8 million, collected spat, and then harvesting 3 and 4, 5 million a year.
Very much a cooperative and a collaborative effort on,
right.
On all
you share
parts
costs in gear and manpower, and then also in the net gains.
Right, as it were, net gains.
Yeah.
That's very good, yeah. Well, thank you very much, Lawrence. Really appreciate you sharing us some of your saltwater tales.
Yes,
as something different, and perhaps, unless you have objections, we'd certainly be more than pleased to have you back and see if you can show us some more things that go on under the surface, as it were.
Right, great.
Thank you very much.
Okay.